Hey guys, so my goal for today is to give you a guide to the practice test, which is a guide to your chapter test, which you will take at the end of this week. So I will be doing one problem like each one, and then you will be able to solve the rest of them hopefully from there. So let's start with the first one. We are solving for x. So when we look at these, we want to think back to our SATMEP or SATMERP. I'm just going to use SAD. So we want to look for any subtraction, addition, which we don't have in this case. Division, multiplication. We notice that there's a 2 here, so I am going to divide both sides by that. That gives me x cubed is equal to 16. And we can move along to our exponents or radicals. Here we have an exponent of 3, so we're going to use our radical to cancel that out because they are opposites of one another. So we get x is equal to the cubed root of 16. So I need to make sure that that can't be simplified anymore. I am going to take the 16 off to the side and simplify it. So that is 4, which I can break into 2 and 2. I want groups of 3, so I am able to take out one group of 3 2's. So x is equal to a 2, and since I still have a 2 left over, that stays on the inside as that. I can't simplify that anymore, therefore that becomes my answer. Here is our number 2. We want to simplify 16 to the power of 3 over 4. So the first thing you want to do here is you want to use your exponent rules to rewrite the problem. Remember that our denominator becomes our root. So here we have the 4th root of 16. And then our numerator becomes our exponent. I can simplify the inside because, well, I already did it up here. So I want 4 of the same number here. And I happen to have 1, 2, 3, 4. So I know that if I were to take this part here, that gives me 2. So this is equal to, replace the inside with just the 2, raise that to the power of 3, which that looks like 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So our answer is 8. Okay, for our next one, again, since it says solve for x, I'm going to keep using my SATMERP. I look for subtraction, addition. Now, I notice that I am adding 5, but that's inside of the parentheses. Therefore, I can't touch that yet. I'm going to move on to division, multiplication. There's no number that is being multiplied or divided, therefore I can keep going, and I look for any exponents or radicals that I might have. I notice that I have the 4th root that I can use here to get rid of that power of 4. So take the 4th root of both sides. That cancels the exponent and the root out, and I am left with just the x plus 5. And then the 4th root of 16. Now, again, I solved it in the first one, but if it helps, I will solve it again off to the side. I'm going to take that 16, break it up into 4 and 4, 2, 2, 2, and 2. This tells me I want a group of 4 of the same number, so I am going to move this up for a second. Take one giant group with all of the 2's in there. So I get that x plus 5 is equal to 2. Now I can address everything that is in the parentheses. So I can start all over with subtraction, addition. I can get rid of this plus 5 by subtracting it to both sides. And get x is equal to negative 3. All right, so for the next one, this one looks new, like we haven't reviewed this yet, but we actually have. This is just started for us. So essentially what this is saying is that we are going to simplify a number to the fourth root. So if I were to give you something, and let's just consider this like a side note for now, if I were to give you a problem like the fourth root of 625. Let's pretend, right? You would have to break this 625 up into something smaller. Say something like 125 and 5. Essentially what you are saying is that the fourth root of 125 times the fourth root of 5 is equal to the fourth root of 625. And that's exactly what they give us here. So we can keep simplifying down our tree just like we would any other problem. It's just that in these, instead of starting at this point, they start us one level in, and we just have to finish it. So I'm going to continue working and say that this is 25 times 5, and then 5 times 5. They should all have the fourth root, but for sake of space, I'm not going to write them. I'm just going to say that this is the fourth root of 1, 2, 3, 4, 5. So 1, 2, 3, and 4. So this wants a group of 4 of the same numbers, which, would you look at that? I have right there. Therefore, the fourth root of 125 times the fourth root of 5 is equal to 5. Because I was able to pull this all the way out. And nothing was left inside of it. Okay, and now we are looking at number 5, which is rationalize the denominator. And it doesn't say it explicitly on there, but you'll be using the conjugates. We want to start off by finding that conjugate. Remember that our conjugate is going to be multiplied by the top and the bottom, and it is the denominator, that binomial, with the same numbers. The only thing that changes is our sign. So we're going to multiply top and bottom by that. The numerator is fairly easy to do. We're just going to distribute it to each one. So 4 times 3 gives me 12, plus 4 times radical 2 is that. So our numerator is done. Now we just have to multiply our denominators. So we are looking at 3 minus radical 2 times 3 plus radical 2. When we did this in class, I used an area model, which is what I'm going to use again. And I'm going to keep the same colors so you could kind of see where I'm coming from with these numbers. And I don't confuse you with that. Okay, so 3 times 3 is 9. 3 times negative radical 2 is negative 3 radical 2. 3 times that is a positive 3 radical 2. And then a positive and a negative will give me a negative. Radical 2 gives me radical 4. I notice that I have opposites right here. So those cancel out, and I am left with 9 minus radical 4. Well, I know that the square root of 4 is 2, so I can rewrite this as 9 minus 2, which gives me 7, and that is my denominator here. Since there's no GCF between 12, 4, and 7, this here becomes my final answer. If they had a number in common, say, for example, this was an 8, you would be able to simplify by pulling out the GCF and dividing each of the numbers that are outside of the radical by that number. But since we don't have a GCF, we can't do that, and our answer is just 7. All right, number 6. So for this one on the test, you'll have to match the equation with the correct graph. But since I didn't want to give you all of that work, I am just going to have you make a table, complete it, so that you can then match the coordinate points with the graph when it comes to your test. And then you'll also have to find your domain and range. So the first thing that I want to do is I want to find what x values are most convenient for me. So I took that inside of the radical and I made it equal to the first 5 perfect squares, which are 0, 1, 4, 9, and 16. From there, I would solve for x to find those perfect squares. So if I subtract 4 to this side, then I get, so subtract 4, and remember I want to solve for x. So I get 4x is equal to negative 4. So I would get x is equal to negative 1. So I'm going to plug in negative 1 right there. I would do it to this, and I would end up with negative 3 over 4, which I don't want to use. So I'm not going to even bother writing that one. I would do it with this one. That would give me a 0. So x is equal to 0. I would do it with this one, and that would give me a 5 over 4, which, again, I don't want to use. Then I would do it to this one. So let me do this one again. Since there's more room, I'm going to subtract 4 to both sides. This is going to give me 12 is equal to 4x. Divide by 4 on both sides. So x would equal 3. And you could keep going in that way, but I already know what my vertex is going to be. It's going to be that where it's equal to 0, which is x is equal to negative 1. So I should be able to determine the direction of my function based on that so that I can find my domain and range. So now that I found that, I am going to substitute these x values into my equation and solve for my f of x. So plug in negative 1. So 4 times negative 1 is negative 4, plus 4 is 0. So negative 0 plus minus 1 would give me negative 1. So that is my vertex. Plug in 0, so that is 4. The square root of 4 is 2. Negative 2 minus 1 is negative 3. Plug in 3, so that is 12 plus 4 is 16. The square root of 16 is 4. Negative 4 minus 1 is negative 5. And of course, I could keep going. I'm just not going to, because I think that that's enough information to give me my domain and range. So I am going to take that vertex, that is this point here, and that would be easier to see if you had the graph. So you could graph this if you wanted to. I just choose not to. And now I want to determine whether that's going to be, for each one, whether it'll be greater or less than that vertex point. So I'm going to look at just my x's for my domain, and I'm going to compare them to that negative 1. So looking at negative 1, are the x values going to be bigger or smaller than negative 1? Well, 0 is greater than negative 1, and 3 is greater than negative 1, so that x will be greater than. Now I'm going to look at just my f of x. I'm going to compare it to the value of negative 1, which is that vertex. So is negative 3 greater than negative 1 or less than? Is negative 5 greater than or less than negative 1? Each of those is less than, therefore, my domain and range would be that. Okay, and our last example for today is going to be this one. We're going to solve, and we are going to have to check for extraneous solutions if necessary. Sometimes it's not necessary to do so. So for this one, the first thing I want to do is get rid of my radical. To get rid of that, I need to square both sides. And that gives me a binomial square. So if I take that off to the side, and I'll do it in a different color so that we don't get confused. That is actually saying x plus 1, x plus 1. I'm expanding it. It's like saying 3 squared is 3 times 3. So x plus 1 squared is x plus 1 times x plus 1. So I'm going to use an area model to multiply these out. If you don't need that at this point, good. But if you still need it, that's fine. So this is plus 1x, this is plus 1x, and this is plus 1. I have my like terms here, so this is going to equal x squared plus 2x plus 1. And I get to bring that down. Because I squared it, the radical goes away. At this point, I can combine my like terms. So I'm going to say, I'm going to add the x to cancel that out, and add the x here, and then subtract the 5 to cancel that out, and subtract the 5 here. My x squared doesn't change, so 2x plus x is 3x. 1 minus 5 is negative 4. At this point, I need to check if this is factorable. Remember that if you can't factor this, that doesn't mean there's no solutions. That means that you then have to use the quadratic formula to find those values. So with any luck, this will be factorable. I'm going to do my A, B, and C. So A is 1, B is 3, C is negative 4. Going to use my diamond. And A times C goes on top, so that's negative 4. B goes on bottom. So I want two numbers that multiply to give me negative 4, but add to give me 3. I'm just going to draw my area model now because I'm using the green. So in the first box, I'm going to use that first term. In the last box, I'm going to use the last term. So two numbers would be 4 and negative 1. Multiply to give me negative 4, but add to give me a positive 3. And then I can, oops, that's a plus, and that's a minus. So pull out the GCFs here, and that gives me an x. That would be a plus 4 here, and a minus 1 there. So 0 is x minus 1, x plus 4. Okay, now I can use the zero product property. X minus 1 is equal to 0. X plus 4 is equal to 0. So I get x is equal to a positive 1 and x is equal to a negative 4. Okay, so at this point, these would be our possible solutions, 1 and negative 4. I need to test them in order to make sure that they really are. So, I'm going to test my solutions. In this first one, I'm going to test x is equal to 1. And in the second one, I'm going to test x is equal to negative 4. So I want to plug those into negative x plus 5 is equal to x plus 1. Alright, so let me zoom in. Negative x plus 5 is equal to x plus 1. So here's a 1 and here's a 1. 1 plus 1 is 2. That one was easy. So then I get negative 1 plus 5 in my radical. That gives me 4. Square root of 4 is 2. Since that is true, x plus 1 is a solution. Now I need to test if negative 4 is a solution. So negative 4, negative 4. A negative and a negative will give me a positive. So the square root of 9 is 3. Negative 4 plus 1 gives me negative 3, which negative 3 does not equal negative 3. Therefore, this is not a solution because it's extraneous. X is equal to 1 is our only real solution. Whoa. And that is number 7. So looking at it, there's a few different ways that the problem can be presented to you. The one I just did is for E, F, and G. And yes, I know I messed up on that last one. It should be a 7x. So if you're watching this, correct that, then you should be able to solve it. For A and B, since it's not a binomial, you should be fine. You just square both sides, and then you could combine like terms from there. For C and D, remember that when you square one side to get rid of the radical, it would also get rid of it on the other side. So then you just solve like we did in chapter 1. And that is about it for me. So here is your chapter 5 practice test. I hope that helped. And I hope you guys are able to complete the rest of it on your own. Have a good day. Be good, be great, be beautiful.